Recursion relation. We have already done the questions on this, how to form the recursion relation. As we discussed, now discuss discuss how to solve the recursion relation and what type of recursion relations are there and how to solve the different type of recursion relations, right? So first, I'm just giving you an example how to solve this. Then I'll go for what type of recursion relations are there and how to solve few of the recursion relations, because I person believe they will not ask the question out of the box, right? A very tough question, but nearly you must know exactly how to solve the questions, right? As we know, we have used this one, a n plus 1 is equals to an plus an minus 1. We have used this Fibonacci series in the like different ways, like how to solve this, right? So by putting the numbers 1, 2, 3, 4, and all so on, right? We know that if we are forming this question as like we have to toss a coin, no two consecutive hits are possible, right? No two consecutive hits appears, right? For that, if I'm forming this, so what is the value of A1 in this case? If we are tossing a coin one time and you are not getting, right? You are not getting two consecutive hits, right? And let the last term is head, right? Ending with head, and no two hits are consecutive, right? So find A1 and A2. What is the value of A1 and A2?
Sir, could you repeat the question?
Right? A1 and A2, right?
Sir, could you repeat the question? Sir, could you repeat the question?
No two terms are side by side hits are there, and last term is hit, right? So what is the value of A1 and A2 or H1 and H2? A1 is 1 and A2 is,
Sir, A2 is 0.
why 0?
Wait.
What about tail and head?
Yeah, tail and head. Yeah, A2 is 1.
1, right? So A1 is 1, A2 is 1, right? So only two values are required for that, right? Because we'll get two unknowns, right? So how to solve this, right? This we have to form an equation, and the equation will be, since it is given an plus 1 is equal to an plus an minus 1, right? We have to take as a polynomial equation as x to the power whatever with the power of, right, an plus 1 and an plus 2, you have to put the powers. So you are getting x square minus x minus 1 is equal to, right? x square minus x minus 1 is equal to 0. From this, you'll get value of x is minus b plus minus under root of b square minus 4ac by 2a. This when you are getting real values, right? 1 plus 1 minus root 5 by 2. 1 plus minus root 5 by 2, right? You are getting two values. One is plus and one is minus, right? The quadratic. 1 plus minus root 5 by 2. So this, very good, very good. So an is alpha 1 plus root 5 by 2 to the power n plus beta 1 minus root 5 by 2 to the power n. Up to this. Any problem or doubt?
So we need to find alpha and beta.
We have to find value of alpha and beta, and this we will find the values as values we will find with the help of A1 and A2.
We just have to substitute the values.
And then you will get alpha and beta.
Sir,
Hmm.
so why did we solve the expression in terms xn plus 1 equal to x to the power n plus x to the power n minus 1?
This is called the recursion relation, right? And this an not defined as the function of the like an be the function of a1, a2, a3 up to an minus 1. So this repeatedly, this will repeat itself. So we are forming a polynomial of this kind where this value will satisfy to each other, right? So in that case, I'm putting an is equal to fn. This fn is nothing but x to the power n form.
Yes, sir.
Right? So now we have to find value of alpha and beta. So A1 was 1, A2 was 1. So A1 was 1. So 1 is equal to alpha 1 plus root 5 by 2 to the power n plus beta 1 minus root 5 by 2 to the power n is 1 on this case. And second one is equal to alpha 1 plus root 5 by 2 to the power 2 plus beta 1 minus root 5 by 2 square. Now you have to find value of alpha and beta. So if we are able to find alpha and beta, just find those values, alpha and beta, then I'll tell you why we are finding this. So what values you are getting for alpha and beta? So from first, we are getting alpha plus beta. And from second, getting 4 is equal to, this is 2, right? 4 is equal to alpha times 5 plus 1, 6 plus 2 root 5 plus beta 6 minus 2 root 5. I can cancel out with 2. I'm getting alpha 3 plus root 5 beta 3 minus root 5 is equal to 2. And this first one, root 5 is equal to 2. Can you get alpha and beta from this?
मैंने अल्फा का वैल्यू दे दी।
गड़बड़ लग रहा है. It's not. I guess it would be irrational or something.
सर वो रैशनल नहीं हो जाएगा क्योंकि मैंने A1 और A2 को इक्वल करके तो एक मिनट तो नहीं सही किया।
Both are not equal, in fact. Who is not there? In fact, alpha is coming as 1 by root 5 and beta is coming as minus 1 by root 5. I guess so. So this value is satisfying in both the case. So I guess alpha and beta could be some value like this. Now, if you are getting alpha and beta, then you have to write an is equal to alpha, and the root was right x1 to the power n plus beta x2 to the power n, right? Now put the value alpha is 1 by root 5, 1 plus root 5 by 2 to the power n plus beta minus 1 by root 5, 1 minus root 5 by 2 to the power n. This is your recursion relation. So you can get any value. If you want to find a 10, right? Put n is equal to 10. If you want to find 20, n is equal to 20, right? You can put the value. Then by the binomial theorem and all, you'll get the number. Is this okay? Sajina, is this okay?
So
Clear now? So that's the reason we were finding alpha and beta. This is the case when roots are coming real, right? This is the case when roots are coming real and the homogeneous equation or the linear equation is given, right? What is this linear and homogeneous equation? Just I'll tell you. Okay, done everyone? So, few of the terminology we have to understand. First is the order, right? First is the order of the recursion relation, right? Order of recursion relation. Right? Let any function is given, right, in terms of f naught plus f1 a n minus 1 up to f r n a n minus r is equal to some function gn, right? So that will be difficult to understand exactly how this is going, right? So I'm writing in the simplest form an plus, right, 5 a n minus 1 is equal to 0. If I'm writing something like this. So see, there are two terms. One is an and second is an minus 1. So the difference of these two, n and n minus 1, this is called the order, right? So if this is coming as 1, the number 1, right? So this is called order 1.
Sir, if in place of n minus 1 there was n minus 3, then would the order be 3?
Order will be 3.
Okay,
right.
sir.
Right? So this we have to see like how this is written in this form. If I'm writing an plus 2 an minus 1 minus 3 an minus 2 is equal to 0, right? So see, the minimum is n, maximum is n, and minimum is n minus 2. So difference in this case will be 2. So the order will be 2. Is this okay, everyone? So I can say in this case, I'm starting with n and going to n minus r, right? So in this case, right, the functions are given in all the form. So this is called R order of recursion. Is this okay? You
Yes, sir.
all know what is the meaning of this order. This order is different from the Fermat. So what we should have done earlier. Note down.
Sir, on the right hand side, you have written G is a function of.
N, N, N. So the role of Gn is there, right? The role of Gn is there, right? You will get the numbers on that also. So first is, right, order. Okay. Done, everyone? Second is called linear or non-linear. Linear or non-linear, right? So if the numbers are given or this thing like the recursion relations are given in the multiplicative form. Something is a plus minus form is a different form. Like I'm saying ki 2an plus 3an minus 1 is equal to 0, right? An plus 5an minus 1 is equal to 0, right? So these are called the linear form, right? Like we are not. But what is non-linear? If I'll write one of the non-linear form, now you'll understand exactly what is the meaning of this. Like an minus 2 plus an minus 1 is equal to 0, or an minus 2, an plus an minus 1, an minus 3 is equal to 1, right? So these are called non-linear. Is this okay? The solution of linears are different, solution of non-linears are different, right? We have to take care of both this, right? Linear and non-linear, right? And is this okay, everyone? Okay, now,
Sir, 1 second. Could you scroll up 1 second?
yeah, please.
Yes, sir. Thank you, sir.
Next terminology is called homogeneous. What is the meaning of homogeneous? Anyone explain this?
Same order throughout.
That same degree.
Homogeneous
The
or
recursion should be in the same degree.
yes, very good. Same degree of what?
Same degree of power.
Very good. So how to get this key homogeneous or non-homogeneous? Like if first term is an minus 3, an minus 1 is equal to 0. Right? I'm writing something like this. And second time I'm writing an plus 2, an minus 1 is equal to 2. Right? So this is homogeneous and this is non-homogeneous. Because the degree, right, this having 1 degree, this having the 1 degree, and I'm equating with this 0. But in this case, these two having same power, but this term having power 0, right? But constant term is coming, right? So this is called non-homogeneous. Everyone is understanding this? Like in coordinate form, right? Coordinate form, if I'm writing x square plus y square plus 2xy plus 3x plus 5y plus 2 is equal to 0. Is this homogeneous or not homogeneous?
Not homogeneous.
are not homogeneous because x square plus y square have different degrees of power, and
This
3n
having
plus 5.
two, this having two, this having two, but these three, these two having one, and this having zero. Right. If I'm not writing 3x and 5y, now this is homogeneous or not homogeneous?
Still not homogeneous because the constant is there.
Right. And if I'm removing this, now this
Now
will
it will be homogeneous.
be homogeneous, right? So homogeneous and non-homogeneous, right? Okay. So I'm writing few of the, like, you have to play with these three terminology, right? So just I'm writing few of the recursion relation. Just you have to write it down. These are three things: order, linear or non-linear, and homogeneous or non-homogeneous, right? Linear, non-linear, homogeneous, non-homogeneous, and order, right? Okay.
Sir, in the second part, you have written an plus 2n into an minus 2.
2n into an minus 2. This is like recursion relation. Solving recursion relation is nothing but you have to solve the telescopic series, right? Few of the cases, just you have to go with the telescopic series, how to solve the telescopic series. That's it. A few questions will do on that, right? Not required to go in a lengthy way, but obviously, few things we have to know, that we'll know. Done, everyone? I guess this is very simple, right? Directly only you have to write down the answer. Now, see, first one, linear, non-linear. First one,
First one is linear.
linear, homogeneous, non-homogeneous.
Sir, it's also homogeneous.
Homogeneous.
Order,
One.
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 Second one, linear, non-linear.
Non-linear. Non-linear.
Why non-linear?
Sir, because there is
The
another.
is present.
Why non-linear? Explain this. Why non-linear? This one. Why you are
The an has power 1 while 2 and an minus 2 has power 2.
That's not homogeneous. Non-linear is.
non-linear? Why non-linear? Huh? No two terms of an are multiplying, so this will be linear, right? Homogeneous, non-homogeneous.
So that's not homogeneous because it has degree 2 in the second one.
Degree 2, n is not an. N is n only. Right? N is n only. This is an, this is 2n. 2, like any number is there, and this is an minus 2, right? Homogeneous order. Okay, tell me third one. Linear, non-linear,
Sir, it is linear.
Linear,
homogeneous, non-homogeneous.
homogeneous,
Homogeneous.
Wait, this is one.
Non-homogeneous
not
and one
homogeneous.
is present.
non-homogeneous,
One is there.
Order
1.
1,
right? This is linear, non-linear.
non-linear,
Not
Not
linear.
Good. This is homogeneous, non-homogeneous.
Not homogeneous.
non-homogeneous.
Why
Who will-
non-homogeneous?
The an minus 1 consider degree
And this
2.
is order
Uh, 2.
2, right? This is linear, non-linear,
Linear.
linear,
homogeneous, non-homogeneous,
Homogeneous. Not
Non-homogeneous.
homogeneous.
non-homogeneous,
order,
2.
2.
right? So, but obviously, when we have to solve, we have to take care of this, right? Each and every, right, homogeneous, non-homogeneous, constant, non-constant, and all, this having different solutions, right? So we have to solve by different formulas for that, and for every this thing of recursion formula, we have the formulas, right? So we have to remember all the formulas, but I don't think like we have to go till that, but little bit we have to know, right? I'm starting with a question. I hope everyone will get that. An is equal to 2 by 3 an minus 1 plus n square minus 15. N greater than equal to 2, a1 is equal to 1. Find an. Take your time. It's a simple question. As I said, this is same as what you have already done as a telescopic series. Just you have to relate this as a telescopic series. So 100% you'll get the answer. May I start this?
So one more minute.
This will take time. Like you
But
have
I understand the question a bit because here an is already given, right?
Now you have to establish the formula of this. A1 is given, na beta. A1 is 1 given. A1 is given as 1.
No, sir. The doubt I had is that you had already given AN there. So that's why I got a little confused.
What?
Sir, it's asked to find AN, right? But in here AN is already given.
An is given means An you have to find in terms of like the constant. This is the relation given, beta.
Oh,
Relation
okay.
is given. We have to just find the value of An.
Yes, sir.
This is the first formation. This is called first order linear recursion relation. The order is 1, right? The constant 2 by 3 is inserted between, and the Gn is again n square minus 15. Rishabh was asking na कि sir क्या Gn क्या है?
Yes, sir.
Gn
Actually,
was
I after you said na n का काम आएगा, so I
हाँ,
started going according to that only. I factorized the left. I took the an minus one on the left side. Then I formed a homogeneous equation.
very good.
The
Good,
first part
good.
which we did, I did it as x into x minus 2 by 3
Very good, beta.
equal to n square minus 15.
So everyone, see, you have to start with this. An minus 2 by 3, An minus 1 is equal to n square minus 15. Right? Again, if you have to find the second term or the third term or something, right? So how we have to go? So if you'll see, just I'm doing a okay. So this is nothing, what I said, this is nothing but telescopic series, right? What I am doing, right? May I start? एक छोटा सा hint देता हूँ, right? You have to just pick that hint. I'm dividing this by 2 by 3 to the power n. Now take your time, think. Now take your time. Now think how to go for this. You have 3 minutes for this now.
So RHS would be 2 by 3 to the power n.
Yes. So 1,
Yes,
2,
sir,
3
because
is
there's no 2 by.
okay. Now take your time. You have 3 minutes for this, right? Take your time, relax. Should I start? Anyone?
Sir, I got an in the form of summation.
Very good. Very good. That's required only. Very good. Ultimately, we have to solve this, right? But
Yes, sir.
if you are getting an is the form of summation, na, so now we have to solve only the summation part. Should I start now? Done, everyone?
Sir, 1 minute.
Okay. See, should I start?
Sir, I've sent something.
Wow. Very good. Very good. So if just I'm saying this an by 2 by 3 to the power n is nothing but some xn. So a n minus 1 by 2 by 3 to the power n minus 1 will be xn minus 1. So now I can say this is xn minus 1 is n square minus 15 by 2 by 3 to the power n. Is this okay? Now put the values of this n as 1, 2, 3, 4 up to n. So what I'm getting xn minus x1 is equal to summation of, right, this r square minus 15 by 2 by 3 to the power r or 3 by 2 to the power r is equal to starting from 0 से start नहीं हो रहा 1 से, this is starting from 2 to I guess all you know how to find the formula for this. You
So
know how
once
to
again
find
आप
formula.
बोल सकते हो?
You know how to find summation of this? This one r square minus 15. This summation. This one too, everyone knows that. This one is a GP series.
Sir, GP combined with another sequence.
First. Second, if I'm asking r into 3 by 2 to the power r, how to find this? You know this? AGP series. Right?
Yes, sir.
The third is when I'm saying r square into 3 by 2 to the power r. Right? 2 times I have to apply this formula. 2 times I have to apply this formula, or we can use the differentiation also, but so you know how to find this now. Everyone, write down yes in chat, please. So I'll be sure that you know. If you don't know, so we have to go for this. And feel free to ask like, okay. Third one, okay. Third one, or the first one to you all know na, Sanjana, it's okay na beta? Tanmay, okay na? First one?
Yeah.
Now first and second, right? see, S is equal to summation R is equal to 2 to N R into 3 by 2 to the power R. So the summation is S is equal to 2 into X. I'm writing this as X, right? Plus 3x square plus 4x cube up to N x to the power N. Is this okay? Okay. So this is the AGP series. This series is known as AGP series. Arithmetico-geometrical progression, AGP series, right? When I have to solve this, simply what I have to do, find the common ratio. What is the common ratio in this case? X. So multiply this X with S and write down this as N plus 1. Now, subtract both the terms. Right? This will be S1 minus X is equal to 2X plus. Right? This will be X square plus X cube up to X to the power N minus N X to the power N minus 1. Is this okay? This is the GP series. The first term is given, last term is given, number of terms are given. So we are able to find this. This is for linear when you are multiplying with the linear. Right? Okay, for like this one is, everyone is comfortable with this?
Yes,
Yeah.
sir.
Right?
Yes.
And for the third one, just note it down. Then I'll go for the third one. Take your time.
Sir, can you scroll up?
Little bit. No, it's okay.
Yes, sir.
You can solve this for R cube also and a different like numbers also. Also with the help of differentiation, you can find summation of this. N plus 1. This is written as N plus 1. This is N plus 1, right? This is N plus 1, N x to the power N plus 1. I'll show this by differentiation also. We've done this. Right? Okay, done everyone?
Yes, sir.
See, with the differentiation, this is always easy. Or if the series is going to infinity, the most important part when the series is going to infinity, 100% use the differentiation only. Now, 100% you have to use the differentiation only. But see, if not going to infinity, 1 plus x square up to x to the power n. What is the formula for this GP? What is,
1 minus
A to the A into R to the power N minus 1 by R minus 1.
right? Okay, everyone? Right? What I'm saying, differentiate this. If I'll differentiate this, the differentiation of 1 is 0. Differentiation of this is 1. Then 2x plus 3x square plus 4x cube up to n x to the power n minus 1. And the right side, the division rule of differentiation, I hope you all know this. Differentiation of this n x to the power n minus 1, x minus 1 constant minus derivative x to the power n minus 1 upon x minus 1 the whole square. This is the answer.
Yes, sir.
This is the answer of the question. You have to put x is equals 3 by 2. That's it. Either you have to go by this complete thing, or just you have to do something like this. You have to subtract 1 from this. Is this okay, everyone? Aryan, is this okay?
Yes, sir.
Anmay, okay?
Sir, the only confusion I had in the first was कि आपने AN का format दिया था फिर वापस find AN लिखा था तो इसीलिए थोड़ा confuse हुआ था उस time.
Okay, this one, right? What if when we have to find, right, in like the question was given r square into x to the power n formation. So in this case, you have to find r square x to the power n. How to find this r square x to the power n, right? Means the summation what we have to find 1 square x 2 square x square plus 3 square x cube up to n square x to the power n. Right? Again, same theory, same fundamentals, same thing you have to do, nothing new, right? Again, you have to do the same thing. S into x is equal to 1 square x square plus 2 square x cube up to n minus 1 whole square x to the power n plus n square x to the power n plus 1. Is this okay? We are multiplying with x and just writing the same thing, right? Subtract minus, 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 minus. So what I'm getting s 1 minus x is equal to 1 square x plus, if you'll see, this is 2 square minus 1 square is 3 x square plus 5 x cube plus 7 x to the power 5 x to the power 4 and so on. And the last one will be 2n. N square cancel out, 2n minus 1 plus 1 x to the power n minus n square x to the power n plus 1. Is this okay? And we have already found this. नहीं? ये तो वो वाली series आ गई ना? That series we have already worked on that. AP and binomial AP series and the GP series. AP and GP series, the 3, 5, 7 is the AP number, and x square, x cube, x to the power 4 is the GP number. So we have to apply the same concept twice. Then you will get the same result. Or you can use the differentiation also in this question. How to use differentiation?
Previous equation में x multiply करके then differentiate again.
Not bad. Or else what you can do, you can write this r square x to the power n, right? You can write this summation of this as r square minus r x to the power n plus r into x to the power. You have to differentiate 2 times the original equation. You have to differentiate 1 time the original equation. Kavyan,
Yes.
right? This will be a better one. Please note down, everyone. Please note down. Right? You have to give time on this, right? This is not simple concept, right? And the usage is so huge now. If you are able to use these formulas, so obviously now like lot many questions, you'll get exactly how to solve this, right? In a few steps, you will get the answers. So this is the concept, right? I hope you all understand this. Good, everyone. We were talking about which one, Sanjana?
Sir, sigma r square x raised to n.
This one, this one.
Yes.
No, I'm not differentiating this. What I'm saying now, just I am subtracting r from this and adding r. So this number is r minus 1 x to the power n. Right. So
Okay.
what will happen if I'm differentiating this function? One time I'm getting 1, 2, 3, 4, right? The second time I'll differentiate this now. See, the left side will be 0. This will be 1 into 2 into only 1 into 2, right? Plus 2 into 3 into x plus 3 into 4 into x square and n into n minus 1 x to the power n minus 2.
Okay,
Right?
sir.
Directly I'm into the answer, right? This is nothing but r minus 1.
Yes.
Right? Okay, everyone. Now, so we were doing like how to write down the different recursion relations, right? So recursion relations, right? Mostly you'll get the questions, right? As we have done. First one was this, right? Second, I'm giving on this kind or this type is an is equals to an minus 1 plus 2 into an minus 2. N greater than equal to 2. A naught is 1. A1 is 3. Right? Find an.
Sir, once like the previous question, could you scroll up?
You have to find the roots and then go for the solutions, then alpha and beta and all those things. Right? All
Sir,
this.
I'm asking you to show the previous
Acha,
question.
previous one. Okay.
एक
This
बार उसका पूरा working.
this one,
Sir, yes.
we have started from there. It's difficult to come in a one screen. If you'll be okay, then I'll go for the another screen.
So you can go to the other screen. Yes, sir.
One more. This. Okay.
Yes, sir.
Now, this is your question. Okay, everyone, do it fast. This is a simple one. This is the simple one.
What was the first question?
Oh,
First,
question we have
second
already done. We have already done from like in the same way you have to do this question. That's it. In this question, you have to find the recursion AN sequence, recursion sequence, what AN should be. Right? If I'll give you 5, A5, A10, A15, so how to find those numbers, right?
So you have to find the value of the answer.
AN.
Yes.
Good. Then take common x to the power n minus 2, then solve this, then alpha, beta, and so on. . Like if I'll give you what is the value of A10, the numerical value, right? You have to find A10, right? What is the value of A10, right? Try this, try this. You have 3 minutes, everyone. Take your time. मैं स्टार्ट करूं? वेरी गुड, वेरी गुड। मैं ऋषभ, काव्यम, वेरी गुड एवरीवन, बहुत अच्छे, बहुत अच्छे। बस यही चाहिए। आर्यन,
सर इक्वेशन में गया, आई मीन लाइक अल्फा बीटा के टर्म्स
कैलकुलेशन
में।
चेक करो बेटा। टू द पावर 12 कितना आ जाएगा? देखो ना, 2 to the power -1। 1024 हो गया, 4096, 4095।
सर 810 है ना?
810, 810 चाहिए था अपने को। स्टार्ट करें? बहुत अच्छे, काफी
Yes,
लोग
sir.
हैं। वेरी गुड, वेरी गुड। See, this we can write as x to the power n is equal to x to the power n minus 1 to x to the power n minus 2. Or this will be x square minus x minus 2 is equal to 0. And this will be factorized as x minus 2, x plus 1 is equal to 0. So x1 is coming as 2 and x2
X is coming as 1, minus 1.
right? So I can rewrite this as any xn is equal to an xn is equal to alpha time 2 to the power n
Plus
plus
beta into minus 1 to the power.
yeah. And few values are given. A naught. A naught means alpha plus beta is equal to 1. And A1 means 2 alpha minus beta is equal to 3. Right? So this alpha is coming as 4 by 3. Beta 1 minus 4 by 3 minus 1 by 3. Alpha and beta, put the values of alpha and beta. Right? So what I'm getting in this? So this an is equal to alpha 4 by 3 into 2 to the power n minus 1 by 3
into minus 1 to the power
n. So 810 you have to find.
So that will be 4095 by 3.
Minus 10 minus 1 upon.
So won't it be 4 by 3 into 2 to the power 10? Yeah.
Something like this. What number is coming?
4095 by
4095 by
1365.
136.
65.
yeah, sir.
Sanjana, calculation. Aryan, what is this? 4095 by 3.
4095 divisible नहीं था 3 से.
सर मैंने 1 की जगह 0 ले लिया
Which one?
सर
Alpha,
it
beta,
was
beta.
alpha beta.
Array, it will never come 0.
Yes, I made a mistake.
Right? So if real roots are coming, exactly this you have to solve in this way only. Right? But if roots are not coming as real, it's coming as imaginary roots, you have to go with the same process as I'm giving you. A naught is equal to 1, A1 is equal to 0, and an is equal to 2an minus 1 minus 2an minus 2. Find an. This, right, this is the first concept, right? Well, in fact, second concept we are doing. This is a linear homogeneous recursion relation, right? With constant coefficients. Coefficients are not varying in terms of n. If you'll see, these are the constant one, right? It's not varying as one, right? Earlier, it was the function in n, right? So only two like relations we have to just, we have started this, right? So now you have to find again A10 or something you can say, right? Value of A10, if possible. This one is a good one, so take your time.
सर इसमें से इक्वेशन में कॉम्प्लेक्स रूट्स आ रहे हैं.
You know little bit of complex number,
Yeah, sir.
apply. Try to apply this. Okay. It's okay, right? Only we have to use the formation 2, 3 formula of this, right? Under root of -1 is I only, right? First and second, De Morbius theorem cos theta plus I sin theta to the power n. The formation goes as cos n theta plus I sin n theta. We'll do that, right, later on. Only these small things for the calculation part only we have to use. Huh?
Saurabh said,
Not bad, Aryan. But if okay, is it possible to write it down in terms of sine and cos? Are you able to write it down in terms of sine and cos? This one.
sir, could you say it again? Outside a progression is going on. So that's why I couldn't hear. Sir, could you say it again?
Is this possible to write it down, what you have found, write it down in terms of sine and cos, sine theta and cos theta, right? If we are able to write it down in sine and cos now, so it will be easier to solve this. We can easily use the De Morbius equation, this one. Right. Should I start? Done, everyone?
So I got the equation. I'm trying to convert it into cos and sine.
Okay, okay. Theta is the angle, what you are finding that, right? Just a minute, give me 2, 3 minutes for the equation. Just find the equation in terms of I only, right? Okay.
Sir, I'm sending the equation 1 minute.
Very good. Very good. This type of equation we require, right? Now the complex solution would be there, right? But it's okay, right? First we have to go with this. So an is equal to 2an minus 1 minus 2an minus 2, right? So this will be x square minus 2x plus 2 will be 0. So x is equal to minus b plus minus under root of b square minus 4ac by 2a. X is 1 plus minus I, right? Something like this. Okay. So this 1 plus minus I is, one number is 1 plus x1 is 1 plus I, or x2 is 1 minus I. Say this carefully, everyone, right? This x1 I can write x1 as root 2 times 1 by root 2 plus I into 1 by root 2. And x2 again root 2 times 1 by root 2 minus I by root 2, right? So x1 I can write root 2 cos pi by 4 plus I sine pi by 4. And x2 I can write root 2 cos pi by 4 minus I sine pi by 4, right? This is x1 and x2.
Yes.
Right. Okay, right? Very correct, right? Now it will be easier for us to apply the formula, right? So now the an will be alpha times root 2 cos pi by 4 plus I sine pi by 4 whole to the power n plus beta times same root 2 with minus sine cos pi by 4 minus I sine pi by 4 to the power n. पहले यहाँ तक note, just note it down. Is this okay, everyone? Sanjana, is this okay?
Yes, sir.
Right? Up to this step is okay now. Only I'm representing this 1 plus I or 1 minus I as cos pi by 4 and sine pi by 4. Tanmay, is this okay?
Yes.
Kavyam Risal, is this okay?
Yes.
Yes, sir.
Okay, now. Then A1 and A naught and A1 was given, I guess, na? A naught is 1 and A1 is 0.
So can we convert 1 plus minus I to cos and sine terms in the end?
We have converted this, na? 1 plus minus I multiply and divided by root 2.
So like after calculating alpha and beta.
That will do. For that, I'm waiting. Everyone will note it down, na? Then that I have to show. So what is the value of alpha and beta is coming? So now I have to find alpha and beta, right? So if I'll put n is equal to 0, so this is 1 is equal to alpha plus beta, the first equation. When I'm putting n is equal to 1, so this is 0 is equal to alpha. 1 is root 2 times, right? Or I can write no use of root 2 in this case, plus beta times 1 minus I, right? Alpha plus beta is 1. So this is alpha plus beta plus I times alpha minus beta is equal to 0. Alpha plus beta is nothing but alpha plus beta
1.
and alpha plus beta is 1. So alpha minus beta is minus 1 by I or I. So alpha plus beta is 1, alpha minus beta is coming as I. So can I get the value of alpha and beta from this? Is this okay, everyone?
Yes, sir.
So what the value of alpha and beta we are getting? Just find the value and put for an.
Sir, alpha we are getting 1 plus I by 2.
1 plus I by 2 and beta is
And beta is 1 minus I by 2.
very good. Beta is
Sir,
1 minus
sir, we
I by
can convert this again also in cos pi I by. And
the same thing is coming now. So I'll write n ke jagah n plus 1.
yes, sir.
In place of n, I'll write n plus 1. Right. So now you can see this an, note it down till this. Okay, everyone. This is one of the beautiful equation, right? Okay, done. So now what I'm writing on this is an is equals to 1 plus I by 2 into, this is cos pi by 4 plus I sin pi by 4 to the power n and 2 to the power n by 2 plus 2 to the power n by 2, 1 minus I by 2 cos pi by 4 plus I sin pi by 4 to the power n. Is this okay? Is this okay, everyone? Now, if I'll multiply with root 2 and divide by root 2, multiply this root 2 divided this by root 2. So again, this is cos pi by 4 plus I sin by 4. This is same and these two are same. So I can write an is equal to 2 to the power n by 2 minus half for this. And this is cos pi by 4 plus I sin pi by 4 to the power n plus 1 plus cos pi by 4 minus I sin pi by 4 to the power n plus 1. Is this okay till this term? So the de Moivre's theorem, this angle coming into, right, in place of this. So an is equal to 2 to the power n minus 1 by 2 into, right, both sine term cancel out. This will be 2 into cos n plus 1 pi by 4. So no worry on this now. When we'll do complex number now, this will be the easiest term, right? So no worry on this, right? We'll solve that. Cos n plus 1 pi by 4. So ultimately, we are getting the answer in the simplest form. When I have to find A10, so only we have to write 10 plus 1 by 2 into cos of 10 pi by 4. Right. 10 pi by 4 is nothing but 5 pi by 2. And what is the value of cos pi by 2?
0.
0. So A10 is nothing but 0. Right. So this could be the a very calculative one, but ultimately you are getting a very, very, very simple answer, right? Okay. Okay, everyone. Anyone want to ask anything on this?